everyone. I have to show you some examples on how to solve different problems of differential equations. So, this is the first problem. So, we must first write the equations, which is y minus x squared dy plus 4xy dx equals to 0. Then multiply both sides with 1 over 1 minus x squared and 1 over y. So we can now get an equation integrate both sides. So we have now the du, so substitute then this is 1 minus x squared plus ln of c. Then so we have now the equation, which is y equals absolute value of 1 minus x squared raised to squared times c. So we have given a condition, which is y equals 9 when x equals negative 2. So when y equals 9, thus y equals 1 minus x squared raised to squared. To c equals to 2. So the following solutions of the equations are y equals 1 minus x squared raised to squared, y equals 2 times y minus x squared raised to squared, and y equals 0, with the limits that x should be less than or equal to negative 1 and x should be less than or equal to 1 and greater than or equal to negative 1 and x is greater than or equal to 1. So this is now the answer. So here's the next problem. Solve the equation and discuss the family of integral curves. So we now write the equation. I think it is an homogeneous equation. So we must test whether the equations is in the same degree, or we must test whether it is an homogeneous equation by letting y equals to yt and x equals to xt. So we have substitute So this is an equation of the same degree of t, which satisfies the condition that if a function of f possesses the property of f with the function of tx ty is equal to t to the n times x y. For some real number n, then f is said to be a homogeneous function of degree f. So since it is a homogeneous, we let y equals to ux and get the derivative. So dy equals to u dx plus x du. Then substitute the value of y and dy to this equation. So x minus 2 times ux u dx plus x du distribute. So we have ux dx plus x squared du so we have dx, then combining 2ux, 2u squared, x minus 2x, 2x, factor out the x, we get x 2u raised to u squared minus dx. Multiplying both sides with 1 over x. By multiplying again with 1 over x, you can get dx over x that now integrate on. Before we integrate, we have to factor out first the 2. So over x minus 1 half by letting t equals to u squared minus u plus 1, then we get the derivative dv equals to 2u by u, also negative 1 plus 2u. So dx over x we have to substitute the value of u, which is equal to y over x, with this condition that y equals to ux. So u equals to y over ln of x is 1 half. By simplification, we get y squared minus xy. So,
Rating factor ni mo aning price is over 100. Is over 100. Rating factor.
so 1,
Okay.
plus c equals to y squared minus x1 plus x squared. We are asked to discuss the family of integral curves. So the family of integral curves is that if c is greater than 0, the curves are
C over dt.
elliptic. If c equals to 0, the curve reduces to the single point 0, 0. And if c is less than 0, the curves have no real trace. So this is the answer, and this is the family of integral curves. For problem number 3, find the particular solution of each of the equation which satisfies the indicated conditions, which is fx equals 1, y equals 2. So let's perform the equation. Y prime equals to y minus 2xy over x squared. That's y 2. So dy over dx minus 2x y over x squared. So I get 1 over x squared it is now obvious that it is a type of linear differential equations. So since it is a linear type of differential equation, we must find an integrating factor with the value of v. So by finding an integrating factor, we have a formula that v equals to e, the integration of, and the integrating factor is 2 over x squared dx. b, I mean e to the 2x is equal to dx. Integrate this equation and we get negative 2x raised to negative 1. So we have now an integrating factor which is e to the negative 2x. So since we have an integrating factor, we will now multiply the integrating factor to this equation. So dy over dx is 2y now multiply the integrating factor. What we do now is we are getting a relationship with the integrating factor times the dependent variable equals to the integrating factor times the function. So it is like this: y times e negative 2 over x equal to e times negative 2 over x squared. And thus, by integrating, we can get y times e to negative 2 over x e to negative 2 over x is to negative 2 by letting u equals negative 2x is to negative 1, which is from this one. By letting u with this negative 2 over x, can get du equals 2x negative 2 dx. So du over 2 So now y equals to 1/2 plus ce to the 2x. So this is now the particular solution. Then we should find the equation which satisfies that the indicated condition, which is y of 1 equals to y 1 equals to 2. So equals to 2. So when x equals 1, y equals to 2. 2 plus 1 half into 2 over 1. 4, 1 plus 2. 2. So we get the value of c, and then we substitute the value of c to this equation. Thus we can get y equals to 1 half plus 3 halves into c into x. So minus 2. So now that is x equals to 1, y equals to 2. And we have to check that if x equals to 1, it should be that y is equals to 2 also. So y equals to 1 half plus 2 halves. 8. Then 2 minus 2 times 1, 2. Y equals to 1 half plus 3 halves. E to the 0. So e to the 0 is 1. So 1 half plus 3 halves is equal to y equals 2, which is true that when x equals 1, y equals 2. Here's the next problem. Show that there are two values of c for which y equals c minus x squared is a solution of the equation y prime equals x squared plus y plus 1 times x squared plus y minus 3 halves plus 1 minus 2x. Find these values and solve this equation using each of the particular solutions determined by these values of c. Y prime equals to x squared plus y plus 1. Given that y equals to c minus x squared, get the derivative from then substitute the value of y prime and the value of y to this equation. Thus, negative 2x equals to x squared plus c minus x squared plus 1 x squared minus 3 halves plus 1 minus 2x
mangkod na siya yung mga mangkod na tayo.
Still x. And also 2x, 2x. To find the value of c, since it is in a quadratic formula, we may use the calculator in order to find the value of c. So by using the calculator, so c1 equals to 1 and c2 equals to negative 1 half. So therefore, the two general equations is, by substituting the value of the c to this equation, we can get y equals to 1 minus x squared and y equals to 1 half plus x squared. So this is now the two general equations with the value of c1 equals to 1, c2 equals to negative 1 half.
Go.
For the last question, if P pounds per inch squared is the atmospheric pressure and rho pound per inch cube is density of air at a height of h in above the surface of the earth, show that dP over dH plus rho equals to 0. For letter B, if P equals 14.7 pounds per inch squared at sea level, and if it has fallen to half this value at 18,000 feet, find the formula for the pressure at any height given that P is proportional to rho in isothermal condition. What is the predicted height of the atmosphere in this assumption? At what altitude under isothermal conditions will the pressure be 1/4 its value at sea level? For letter D, work part B, given that P is proportional to rho raised to 1/4 in the diagram here. That this is the height this is the change of height that pressure is to be as to rho. Is the area this is for free body diagram, that would be the pressure P plus B plus 2A, and the pressure with respect to area going upward, pressure is going downward. So consider the figure. Since the fluid is at equilibrium, we assume that the area is uniform. So the summation of forces is equal to 0. Now we add the following assumption, that PA is positive since it is going upward, plus dP plus A as negative since it's going downward, and minus rho AH. By adding up the following conditions, and so that PA is PA, dP PH, and PA. So we have now negative AdP minus rho AdH is equal to 0. Again, multiply yung both sides with the area. We have negative dP minus rho pH equals to 0. So therefore, dP over dH plus rho equals to 0. So we have now the answer that satisfies to the question in letter A, showing that dP plus dH plus rho equals to 0. For letter B, we're asked to find the formula for the pressure at any height and the predicted height at the atmosphere in this assumption. So E equals to 14.7. It said that it has fallen to half this value at 18,000 feet. So 1 half E at 7 pounds per inch squared at h equals 0, and 1 half P at 18,000 feet. Assume that P equals to K rho, or rho equals to Kp, since P is proportional to rho under isothermal conditions. So by substituting the value of Kp to this equation, value of rho to this equation, you can get dP over dH plus Kp equals to 0. So dP over P equals negative K dH multiplication ln of P equals, using the second condition, which is H at 18,000 feet and P equals 14.7 over 2, and we get now that 1 half 14.7 plus of 14.7 e to the negative 3 times 10,000. So now, this, so ln of 1 half equals to ln 15.3%.
Correct.
So we have now the ln of 1 half equals ln of e to the negative 18,000k. So therefore, ln of 1 half equals negative 18,000k. So therefore, k equals to negative 3.851 times 10 to the power negative 5. So hence, P equals to 14.7 e to the negative 3.851 times 10 to the negative 5 h. So 14.7 e to the negative 3.851 times 5 h. Since it is a limiting condition, that what it would be equal to 0 at h is equal to positive infinity. So therefore, it is the formula of for the pressure at any height, and the predicted height of the atmosphere in this assumption is to the positive infinity. For letter C, at what altitude under isothermal conditions will the pressure be 1/4 its value at sea level? Now, we are asked to find the altitude. So h equals known. So P equals 1/4 P sub 0, the 1/4 P sub 0, so 14.7 P equals to 3.675. That 3.675 equals to 14.7 3.851 and to the negative 5h. This equation is from this equation. So, by using this equation and substituting the value of P, we can get the 3.65 equals 14.7 e to the negative 3.851 times 10 to the negative 5 h. So 3.675 over 14.7 equals to e to the negative 3.851 times negative 5h. ln both sides. And there's the ln of 3.675, 14.7, negative 3.851 times 5h. So therefore h is 35998.30 feet, or approximately 36,000 feet. So this is now the the altitude under isothermal conditions, that the pressure be 1/4 at sea level. So 36,000 feet is the answer. Now for letter D, for letter D, work part B, given that P is proportional to rho raised to the 1/4 in adiabatic conditions. So for letter D, that P equals to K rho of 4 rho KP, the 1/1/4 for rho equals to KP raised to 5/7. Substituting the value of rho to dP over dH plus Kp raised to 5/7 is 0. Therefore, dP over P to the 5/7 will be Kph. Integrate that's 7/2 7. Let's see. We will now solve the value for K and C using the boundary conditions used in letter B, which is as H equals to 0 and P equals to 14.7. That's 7/2, 14.7, 2 over 7. Added K times 0, 0, ln of C. So ln of C equals to 7.544. And for solving for the value of K, we use the second condition, which is H equals to 18,000 and P 14.7. So then number 2 times 14.2 over 7. K times 18,000 544 7/2 raised to the 7 and 7.544 equals to negative 18,000 K. That is 7/2 7.53. So therefore, I have now an equation. So we have now the value of K and the value of L and C, and then we substitute it now to these equations, and then 7/2 P raised to 2/7 plus 2 H plus 7.5. So this is now the formula for the pressure at any height. So next is to find the predicted height of the atmosphere. So solving for H, we have, that is 7.53 times 10 H over 7.53. Okay, 1.554. Therefore, H is approximately 100,000 feet. So therefore, this is the predicted height of the atmosphere with this formula for the pressure at any height. So, thank you for listening and have a good day.